Hello friends, myself Rajendra Mahajan presenting my new video on OR topic graphical solution of linear programming problem. Steps for that graphical solution. Step number 1, consider each inequality as equation. This is the first step. We have to consider each inequality, whether it is less than or equal to or greater than or equals to type, as an equation. Second step, plot each equation on the graph. Therefore, we have to use graph paper to plot that equation or lines. Third step, shade the feasible region. Shade the feasible region. If the inequality is inequality constraint is less than or equal to type, then make the arrow direction facing towards origin. This is important step. Whenever inequality constraint is less than or equal to type, we have to make the direction of the arrow facing towards origin. And second, if the inequality constraint is greater than or equal to type, then make the arrow direction away from the origin. Therefore, remember this as an important step to obtain the feasible region. Then the common region is called as feasible region. The common region obtained is known as or called as feasible region. Step number 4, choose the convenient value of z. Suppose it is equals to 0, say equals to 0, and plot the objective function line. Plot the objective function line. Step number 5, pull this line, objective function line, until the extreme point is obtained. Extreme point means maybe maximum or minimum, whatever. Extreme point of the feasible region. In the maximization case, this line will stop furthest from the origin. We have to consider the furthest point for maximization case, passing through at least one corner of the feasible region. Passing through at least one corner of the feasible region. And in case of minimization, the line will stop nearest to the origin. Nearest to the origin, and passes through or passing through at least one corner of the feasible region. This is one way to find the maximum value or minimum value graphically. Another technique is there which I will explain directly in the example itself. Then, after knowing the steps, we try to solve one simple example. Solve graphically the following linear programming problem. Problem is maximize z is equal to 5x1 plus 3x2. Subject to constraints, equations are 3x1 plus 5x2 less than or equal to 15, and second 5x1 plus 2x2 less than or equal to 10, and that x1 and x2 must be greater than or equals to 0. We have to solve it graphically. Therefore, we have two inequalities. Consider both of them as an equation. Therefore, first equation becomes 3x1 plus 5x2 is equals to 15, and second equation becomes 5x1 plus 2x2 is equals to 10. Equation 1 and equation number 2. Then from equation 1 we try to find out two minimum points. First put x1 equals to 0, we get 5x2 equal to 15, means x2 is equals to 15 by 5, it is 3. For x1 equal to 0, we get x2 is equals to 3, and therefore point is 0, 3. Then consider x2 as 0, we get 3x1 equals to 15, means x1 equal to 5, therefore point is 5, 0. We have to plot this on the graph and then join these 2 points to obtain that straight line. Similarly, for the second, for x1 is equals to 0, we get 2x2 is equal to 10, means x2 is equals to 5, and point is therefore 0, 5. And for x2 is equals to 0, we get 5x1 equals to 10, means x1 has 2. Therefore, the point is 2, 0. Again plot this 2 point and join it to get the second straight line. All this we have to perform on the graph paper. And then as both the constraints are less than or equal to type, we have to draw the direction of the arrow facing towards origin. Then shade the common region, and that common region is called as a feasible region. Show that feasible region in the graph. Put z is equals to 0 in that objective function to obtain objective function line. We get 5x1 plus 3x2 is equals to 0. Then we get 5x1 is equals to minus 3x2. Therefore, x1 by x2 is as minus 3 upon 5, means x1 as equals to minus 3 and x2 as 5. Then we plot this in graph. X1, x-axis as x1 axis and y-axis as x2 axis. Then for the first equation, we make these points 2, 4 and 6 on x1 axis, and similarly on x2 axis 2, 4 and 6. Point is 0, 3 and 5, 0. Therefore, these 2 points were to join by straight line like this. This is the first equation of the straight line. For second, it is 0, 5 and 2, 0. Join these 2 points to get another straight line. Then as inequality is less than or equal to type, we make the direction of the arrow towards the origin as I have shown in the figure. Then the common region we have to shade like this. This is the feasible region. Points 0 0 origin, then this is 2 0, this one is 0 3, and we give the names to the corners O, A, B, C. O with 0 0 coordinates, A as 2 0, B we have to obtain by solving that two equations, and C as 0 3. Therefore, if we solve that two equations simultaneously, we get the coordinates for B as, I have written here directly, the calculation I have showed in the next part of this problem. Therefore, we get the coordinates for B as, and this is the objective function line, -3, 5. That point we have to join to origin to get this objective function line. Then we have to pull this line passing through that at least one corner of the feasible region. Therefore, these are the feasible region corner points. B point is with the coordinates 20 by 19 and 45 by 19. Then drawing the parallel line passing through this A and C, this is the first dotted line, second passing through B, and then if we see the distance of that two lines from the origin, the line passing through B is the furthest one, or that distance of point B is more than for that another line. Therefore, that point B at which function is maximum. Therefore, we draw the parallel lines to objective function line and passing through the corners of that feasible region, which I have shown by dotted line. This is the first step to obtain that maximum or minimum value. For this problem, it is for maximization case. The line passing through point B is the furthest from the origin, and therefore that point B is the solution of that linear programming problem, the value of x1 and x2. And substituting the values of x1 and x2 in that objective function, we can determine a maximum value for z. Therefore, performing that calculation, I have performed it in the next part. Here I have also written, therefore, maximum value of z as equation is 5x1 plus 3x2. Substituting x1 as 20 by 19 and x2 as 45 by 19, and then simplifying the calculation of performing it by calculator, it is 100 by 19 plus 135 by 19. Sum is 100 plus 135, that is 235 by 19. And then dividing by 19, we get that term as 12.37. Therefore, this is the maximum value of z, and solution is x1 as 20 by 19 and x2 as 45 by 19. Then another type, by solving the equations, this is the step to get the values of x1 and x2. Solving these two equations of inequalities by elimination technique, multiplying first by 5 and second by 3, a known method. Therefore, 15x1 plus 25x2 is equals to 75, and second equation becomes 15x1 plus 6x2 is equals to 30. Subtracting each term from the first, 15 get cancelled. We get 25 minus 6 as 19x2 as equals to 45, and therefore we get the value of x2 as 45 by 19. And then substituting this in first equation, we get the value of x1. Therefore, 3x1 is equals to 15 minus 5x2. Substituting the value of x1 as 45 by 19, dividing by 3 throughout, we get x1 as 15 by 3 minus 5 into 45 divided by 3 into 19. This is 5 minus 75 by 19. Finding LCM as 19, it is 95 minus 75 by 19, 20 by 19. You can use calculator to perform all this calculation, and therefore that point is, coordinates for B is 20 by 19 and x2 as 45 by 19. Then the feasible region corners points are zero, O as 0, 0, then A 2, 0, B as 20 by 19 and 45 by 19, and C as 0, 3. Then we determine the value of that max z at all these 3 points. This is the another technique to get the maximum value. Therefore, for 2, 0 point, we put x1 as 2 and x2 as 0. 5 to the 10 plus 0, we get the value as 10. Then at 0, 3, we get 5 into 0 plus 3 into 3, that is 9. Then at the B point, that is 20 by 19 and 45 by 19, we get 5 into 20 by 19 and plus 3 into 45 by 19, and then performing all the steps once again, whatever I have performed here, we get that value as 12.37. Then check which one is maximum out of these 3. Here the maximum is 12.37. Therefore, objective function z is maximum at point B, coordinates 20 by 19 and 45 by 19. This is the solution of that L.P.P. graphically, and the maximum value of z as 12.37. This is the required answer obtained by graphical method. Please like my video, share it, as well as hype the video, then subscribe to my channel and press the bell icon to receive the notification for such type of new videos. Thank you. Thanks for watching.